Dear students, in this video you will learn about swing curve and equal area criteria of power system stability. First we will see swing curve. Swing curve is used to determine the stability of the system. Swing curve is a relationship between rotor angle delta as a function of time t. It is used to plot between rotor angle delta versus function of time t. If you plot the graph between rotor angle delta and function of time, it is called swing curve. So, we will get swing curve from the plot between rotor angle delta versus function of time t. So, this swing curve, so we can use to solve by using Euler's method and RK method. RK method is known as Runge-Kutlas method. Swing equation or swing curve we will use to this method to solve. So, already I have been explained first of this video, starting of this video. Swing curve is used to determine the stability of the system. In case of delta increases, in case of delta means rotor angle is increases, indefinitely it indicates instability of the system. So, rotor angle delta is increases with respect to the time t, the stability of the system will be decreased. So, whereas if it reaches a maximum and starts decreases, so it will reaches to maximum value, again it will decrease. So, we can see in next slide graph. So, in next slide we have a graph, swing curve graph. So, there we can observe. So, it will reaches to maximum value, again it will decreases to the 0. The stability of the system when d delta by dt is equal to 0. So, when the stability of the system we can say, so when d delta by dt is equal to 0, we can say that the system is in stability condition. When d delta by dt is greater than 0, then system we can say that instability of the instability. Okay. So, this is about stability conditions. D delta by dt is equal to 0, then we can say the system is under stability. D delta by dt is greater than 0, the system is not in stability, that is called instability. So, coming to the equal area criteria. So, it provides qualitative assignment of transfer stability of the synchronous system. So, EAC is provides qualitative assessment of transfer stability of a synchronous system. It helps in deciding whether a system is stable or not under transient conditions without solving the swing equation. So, EAC is advantage is without solving the swing equation, we can say that whether the system is in stable or unstable or it is there in transient conditions. So, this we can find out using EAC, equal area criterion. Okay. So, consider one swing equation, m into d square theta by dt square is equal to PA, accelerating power. PA is accelerating power. So, multiplying both the sides with 2 by m into d delta by dt. So, we will get some expression, and if we integrating in the both the sides, so we need to integrating. So, we will get a normal equation. So, that is so here we can see the integration part. So, finally, the system is stable when we can say d delta by dt is equal to 0. So, here we can say that d delta by dt is 0, the system is stable, otherwise it is unstable. So, if you simplify, you will get integral del naught to delta PA into d delta is equal to 0. So, this is equation we will get from the swing equation. The physical meaning of integration is the estimation of the area under the curve. So, integration is estimating area under the curve. The above integral indicates 0 area. Thus, the system is stable if the area under PA minus del curve reduced to 0 for some value of delta. The system is stable if the area under PA minus del curve reduced to 0 for some value of delta. So, this is physically possible only when PA has both positive and negative powers. So, where PA is positive when it will be when the synchronous motion is accelerating position. When it will be negative, PA is negative when synchronous motion is de-accelerating. Okay. So, that we can identify from the swing curve. For a stable system, so PA minus delta curve must be in positive and hence so negative area also should be equal. When the system is stable, positive area is equal to negative area. So, this is called when both areas are equal. So, we can say that equal area criteria for stability. Okay. So, this is about equal area criteria and swing curve. Okay. Swing curve is used to determine the stability of the system. d delta by dt is equal to 0, the system is under stable. d delta by dt is greater than 0, the system is under unstable positions. Okay. PA minus delta curves for both positive and negative is equal, then the system is you can consider as a equal area criteria. Okay. So, this is about swing curve and EAC, equal area criteria. In next video, we will see about applications of equal area criteria. So, where we can use these applications in real time for the synchronous missions. So, we will see for different cases. So, one area is more, one area is less. So, those conditions we will discuss in applications of equal area criteria. Okay. Thank you everyone.